Algebra is calculating with symbols representing numbers, and also studying the numbers and their operations. We have already come across algebra earlier. For example, when we studied the commutative rule, we wrote it in the form like this. There A and B represented numbers, so the letter representations or symbol representation of general numbers. And also we could add other expressions. For example, in physics, we could express the distance as some object travels if it's moving with some speed, certain speed, and after a certain time it has moved this distance. So if you multiply the speed with the time, you get the distance it travels. So these are examples of algebraic expressions. Since we have already gone through all the calculation rules, much of this algebra consists of going through examples of how to use it. So first we'll introduce some general concepts in algebra. For example, a variable. These are variables here, for example s, v, and t. There are a symbolic expression for a number. Sometimes there are unknown values, or there could be any number we choose them to be. If we are looking for an unknown number, for example, unknown number satisfying an equation, then we call it an unknown. Or in this case, where we have, for example, have time in the formula, we want to find out things, it's more suitable to call it a variable, because it takes on different values. So in an expression like, for example, 6x plus 3, we have constants. These are constants, and these are called variables or unknowns. And also, if you stand in front, for example here, the constant stand in front of x multiplied by x is also called a coefficient. And this is a mathematical expression. We have a mathematical expression here. And the operations here are multiplication and addition. This mathematical expression, it represents a number. So as a whole, this is a number. If we have two mathematical expressions, for example, 3x plus 2, and another expression, for example, 5x minus 4. Here we have two mathematical expressions. If we connect them with an equality sign, this becomes an equation. So here we have an equation. Closely related to an equation, we can also have formulas. So this we call a formula. For example, if I want to find out how the distance for an object to travel if it travels with the speed of 10 meters per second, then multiplying that with time gives me the distance. So this is not an equation really, but rather a formula. And we can also call it a function. But we will talk more about the functions later. And then we also can have, for example, if we have, again, two mathematical expressions, if we connect them with an inequality sign, which we'll also talk more about later, then we have an inequality here. So this represents an inequality. So now we will look at several examples how to manipulate mathematical expressions and equations and so on. So let's look at an example. So if you have a person throwing something up in the air, so he throws a stone or something up in the air. Let's say that he throws it straight up. And let's say he throws it up from a height of, for simplicity, let's say it's 2 meters. Then how high above the ground is it after a certain time? It can be shown from physics that the height over the ground is given by this formula. So if you have the starting height, and then we have the initial velocity or initial speed up. So let's say that the initial speed up was 5 meters per second. or let's take another 5. Let's take 3. So 3 meters per second, we throw it up. Then it accelerates down to the ground because of gravity, and that is roughly 5t squared. So here is the formula for how high above the ground rock or whatever is after a certain time. If it starts at 2 meters, the starting velocity or starting speed is 3 meters per second. Then the height over the ground is given by this formula, and that's given by physics, this formula. Then we could, for example, find out when does it hit the ground, when does the rock hit the ground, because after a while it will turn and then will come down again. So when will it hit the ground? Then we need to find out when is the height equal to 0. So when is this expression here, or this formula, when is it equal to 0? Then we have an equation. So this mathematical expression should equal to 0. And then we want to find out which time makes this become 0. So then we have an equation. So this is an example of mathematical expressions or formula and equations arising in physics from a real-world example. Another example, for example, if we have a taxi cab ride. So how much should we pay? So the price for a taxi cab ride. If we make a simple model, we have a starting price. So let's say that the fixed price, no matter how far you travel, you have to pay $5. And then depending on how far you travel, you have to pay. So you have to pay per kilometer you travel, or per mile, or whatever unit you want they measure in. So let's say kilometer. So let's say that you pay $3 per kilometer. So if you travel X kilometers, then you should multiply $3 times the number of kilometers. This is how much you pay for traveling, plus the fixed price. So you have here a mathematical expression describing the price of a taxi cab ride. For example, if I travel 2 kilometers, then I exchange X for 2, and then I will find out that this is 5 plus 6, 11. So I pay $11 for that trip. And then, for example, let's say that this taxi company want to double their prices. So they want all prices to double. So how should they change this expression? Yeah, they should multiply it by 2. So this now represents a number. So if you multiply it by 2, we get the double price. So how can we change the formula? Of course, we can leave it like this, but if we want to have it in a form like this, where one part represents the fixed price and one part represents the kilometer price, then we can use distributivity, the rule we have gone through before, and you have to multiply in here. So that will become 2 times 5 and 2 times 3x. So these are numbers now. We multiply in this number, then we'll use that rule, it will become like this. So how can we simplify this? This is 10, of course. This here now stands for 2 times 3, and when it doesn't say anything, it means multiplication. So when we don't write the symbol, it means multiplication. And here now we can use associativity. We can multiply these two first. This is 6 times x, or skipping to write the multiplication signs, this is just 10 plus 6x. So now we see the new expression for our new taxi cab price. Now we have a fixed price of 10, which is reasonable since we doubled from 5. And the kilometer price is also doubled to $6 per kilometer. So this is an example how you can manipulate an algebraic expression. And for example, if we had this expression, we could of course left it like this. Or for example, we could have left this like this. But when we went from here, from this expression to this, we say that we simplified the expression. Okay, so we went from here to a simplified expression, because leaving it like this is not wrong, but it's not the most simple way of representing it. Let's say we have another example where we want to simplify an expression. So let's say we have 6x plus 3. Then we take minus 5x minus 4. So this means that we want to take this minus this. Of course, we could leave it like this, but it could be simplified. It can be written more shortly, succinct. Now we only have to remember that x represents an unknown number or variable. So anything we do here is just the normal rules for calculating with numbers we use. So we have already seen the rules we can use. We have seen that what do we do when we have a parenthesis with a minus sign in front. Yeah, we can remove the parenthesis, but then we have to change the signs of these. So that becomes from plus to minus, it becomes minus to plus. And now, since we have an addition here, but okay, we have a subtraction, but we could write this as, if you want to be careful, we could write this as an addition, adding a negative number. Since we now have addition of 4 numbers, or sum of 4 numbers, we can put them in any order we like, because of commutativity and associativity of addition. So I could put these two first, and I put the constants last. And now in the future we don't want to be that careful when moving around this subtraction. We could have just written directly like this, but what we are really doing is writing as a negative number and moving it around with addition. Okay, now we can simplify, because if you have 6x minus 5x, what does it mean? It means 6 times x minus 5 times x. This is 7, of course. So we have here how should we simplify this? Of course, you could just say you have 6 of something and then minus 5 of something, you have 1 of something. But you can also use a mathematical rule. We can use distributivity, but in opposite direction. That is, we factorize out a number. So instead of this, we can take out the x and put it outside. So this part here can be written like this. And why can it be done like that? Because we can multiply it back. If we multiply it back, we see where we get this. So we can go in both directions. So if we go in this direction here, we say that we factorize out x. But this just keep us sticking to the rules we know. So this is the distributive rule we use, but like in the opposite direction. And now we see 6 minus 5, that is 1, of course. So 1 times x plus 7, and that is x plus 7. So you see now we have simplified this expression to x plus 7. Okay, in the future we won't do all these steps that carefully. But what is really going on is these kind of steps. But in the future, of course, we will make shortcuts and we jump over some steps here. But one should realize that many of these steps, or all these steps, should be followed by, explained by using rules. So let's take another example of simplifying an expression. Let's say we have 2/3 times x plus 4x divided by 5. So how can we simplify this? If we can write this as 2 fractions, then we can just use the normal rules for fractions. What does it say here? It says 2/3 times x. It also says times between 4 and x. And now we know that if we can multiply up this here. Why can we do that, by the way? Because if we had a rule dividing a product, you you should divide one of the numbers. So you can divide it first. But if you start with this expression, you can see it like you have moved up b here. So if you start with this expression, it looks like, this rule looks like if you can move it up here, b. So what we can do here is we can move up x there. So this can be written as 2x divided by 3. So now we can just use the normal rules for fractions. We have to make it the same denominator. So let's multiply up and down so they become the equal. So we multiply the first one with 5. And the second one by 3. Because then we have here 2x times 5. What is that? Yeah, here we have three numbers we multiply. So we can multiply them in any order because we have associativity and commutativity. So we can write this as 2 times 5 times x. Here says times between 2 and x. And here's 15. And also here, 4 times 3 we can take first. Now we have 10 times x, or just 10x. And 4 times 3, that's 12 times x. So now we have the same denominator, then we can add the numerators. And that's another rule for fractions. We see that all the time we are using rules we have learned before. So it's nothing new here. The only thing that's new here that we have numbers that we don't know the value of. They just represent some unknown value, any value. So we can have here 22x up, because 10x plus 12x is 22x. Or if we like, we can write it as 22 divided by 15 times x. So now we see that we have simplified this expression to that. Let's take another example. So all these examples are about manipulating algebraic expressions. So let's say we want to multiply these. So let's say we want to multiply these expressions. Then we can use a formula for multiplication of sums. Okay, this is not really a sum, but we could write it as plus minus 2 if you like, so it is a sum. So then the rule is that we should multiply all combinations. So that times that, that times that, so we have 4. So first 3x times 4x, then 3x times 5. And then we need to keep track of the signs also. Minus 2 times plus 4x, then it's minus 2 times 4x. And minus 2 times 5, it's minus 2, 5. And then we can simplify. Here now we can move around in any order, so we can do the constants first. So that's 12. And x times x, that we have a symbol for, we call it x squared. And here we have 15x. You just have to remember now this multiplication, we can do it in any order. So here we have 8x minus 10. Now we can simplify this. Now we have to like collect them into species, so to say. Here's one species, it's x squared, if you have x squared. We can't really, we can write it differently, but it won't make it more simple in general. So what we can do is to add these two together. So you have 15x minus 8x, that's 7x minus 10. So here we have written it differently. Is this a simplification? It depends on the context. Sometimes it's better to keep it like this. for example, we want to solve an equation, it could be better to have it like this. In other situations, you want to have it like this. So what constitutes a simplification or not depends on the context. But because going from here to here, that's a simplification, because leaving it like this is silly. You should take these two together and just write it as 7x. Okay, let us take another example. This here, it's written very simply, so you could just leave it like this. So there's no real need in itself to simplify this. But let's say we want to write it as a sum. At the moment it's written as a product, because what it really says here is a product of these, the same number, the multiplication of the same number with itself. Okay, so I could have written like I did now and then done all the multiplications as up here. But let us instead use the first quadratic rule, or you had a rule for taking a square of a sum. So if you remember that rule, it was a plus b. You should square it. You should have a squared 2ab plus b squared. If you do it here, we get x squared plus, then we take the double product of these, so 2 times that, and then you should have 3 squared. So this becomes x squared plus 6x plus 9. So now we have written as a sum. And it's not much more we can do with this, because of different species, so to say. We have an x squared here, an x here, and a constant there. And we can't simplify them any further in any easy way. Okay, so let's take another example. We take x minus 4, for example. If we want to write as a sum, we can use the other rule. When we have minus, then it should be minus there. So this is x squared minus double product. So this is 4x times 2, that's 8x. And then plus, since we have plus here, 4 squared, and that's 16. So here we can here we have manipulated expressions using the square rule of sum and difference. Sometimes we have expressions containing two unknown variables. So for example, if we have two unknowns, of course we shouldn't use the same symbol for both. So let's call them x and y, but we could call them whatever, as long as they're different. So let's say we have an expression like 2x minus 3y plus 5x plus 6y plus 1. This can be simplified. So we can group together all the y's and the x. So if I take x together, then we, of course, we can do this in any order. So we have 7x, and we have 6y minus 3y. So that's 3y plus 1. But now we can't simplify any further, because x and y don't really mix that well, because they are two completely different numbers. So we can leave it like this. Then of course, maybe now you find out that, okay, x should really represent 5 and y should represent minus 1. Then of course you could continue here and now calculating. But before you know that, you can't continue. So here you could have continued with 7 times 5, 3 times minus 1 plus 1. So then you can find out exactly what it is. So this 33. But as it stands here, it could be any number basically, depending on what x and y is. Let us simplify the following expression. Can this be simplified? Yeah, we can try at least, see if we can write it more simply. So let's multiply in here first. So 3x should multiply by x, and x times 3x, that is 3, and then x times x is x squared. So you can multiply that there, and then multiply that with that. Then we get plus 3x y. And then we should multiply in y. But then let's leave the parentheses for the moment, because we need to change the signs inside. So let's first multiply in. Here's y times x, or if you like, x times y. And here is y squared times y, so it's minus y to cube. And now we can remove the parentheses. Of course, we can do it directly in one step, but it's easier to avoid errors if you do like 2 steps. So now we need to change the signs here. Can this be simplified? Yeah, this part cannot be simplified at least. So this is 3xy minus xy, so it's 2xy plus y to the third. Let's take another example. Let's use some other letter than x and y. It's not necessary to call them x and y, we call them whatever. So let's say we have a3, so unknown or variables called a, divided by a2 plus a4 times a. So what could we simplify this to? Yeah, here we could use the rule for powers. So this is, you take 3 minus 2. Since the same base, we can take 3 minus 2. And here is also the same base, we can add the exponents. So it's 4 plus 1 should be that. So this is a to the 1, but that's a5. These two now don't really mix, so they are different species, so to say. But of course we could also write it like this if you like. We could take out 1a. But to express it like that or that, it depends on the context, what is the best. So what is the most simplification. But so you could answer like that or that. Because you could leave it like this, but it's a little bit silly, because here is obvious that you can simplify. Let's explicitly show what we've already been talking about. We're talking about factorizing an expression. For example, here we saw the example of that there. So let's say we have like this: 3x squared plus 2x minus 4x to the third. Here we can factorize out an x. Since we have an x in common, all 3 numbers there, then we can take out an x, factorize it out. And since if you multiply back x times this, then it should equal that, so we should have 3x. And we multiply in here, then we should have 2, since 2x is equal to x here. And here we should put 4x squared, since that one times that is that. So here we have factorized out an x. Of course we can go back again if you like, but then we are back at where we started. Let's look at the final example. So let's say that we have 6x squared minus 12x. And here we have x minus 2. Can this be simplified? Yes, it can actually. If we factorize the numerator first. So you see that we have a 6 in common and an x in common in these two. So you can take out 6x. And what remains here then? 6x times something should equal that. And then we must have x. And 6x times this should equal 12x. That must be 2 here then. But now we see that we have this number. This is a number, and this is the same number down here. So this represents a number. So that means that we can simplify this fraction. Just make it 6x. Or if you prefer, you could write it like this, 6x and 1, but that's just the same thing. So this expression could be simplified to that. One should of course say here that to write this expression, you need to assume that x is not equal to 2, because you can't divide by 0. Then we have seen a lot of examples. We can see many more examples, but to really learn algebra, you need to train. You have to calculate a lot, do a lot of exercises, see many examples. So here again, I recommend Swedish and Norwegian readers to look at the books in the reference and do as many exercises as possible. That's how you really learn how to do algebra.